Hello everyone, my name is Adrian Fernandez from Texas Instruments, and I'd like to give a quick demo that features the MSP432 LaunchPad and the CC3100 Wi-Fi BoosterPack. And we'll be creating a cloud-connected sensor that will basically call my cell phone whenever moisture is detected. And we're going to be building that 100% from scratch here today. And I simply want to demonstrate just how easy it can be to create IoT applications with modular hardware from Texas Instruments. So let's go ahead and get started. First, let's take our MSP432 LaunchPad and pair it with the CC3100 Wi-Fi BoosterPack. And really, the whole point here is that through modular hardware, customers can very quickly build a prototype to provide a proof of concept or validate an idea. And now that we've got our hardware put together here, I do now need my moisture sensor. And we worked with a company called Seed Studio to develop this starter kit of modules. Inside of this box is a booster pack, and this booster pack will allow our LaunchPad to interact with the huge portfolio of sensors and actuators that Seed Studio provides through their Grove ecosystem. So I'll go ahead and plug this booster pack onto my LaunchPad. And now my LaunchPad is able to interface with the Seed Studio ecosystem with the help of these various connectors. So inside of this box we have various sensors and actuators, but the one that I'll be using here today is this moisture sensor. And with this ribbon cable, I'll be able to interface it to my MSP432 device. And I'll plug it into this connector here. And what's really nice about this booster pack is that I have nice labels for each of these connectors. So by plugging it here, I can see that my moisture sensor is physically and electrically connected to pin number 23. And that's actually going to be helpful for us once we start writing the software. So here you can see on the diagram I put together just to kind of provide a summary of the system that we're building. So we've got our hardware here on the left side, our MSP432 LaunchPad with the CC3100 Wi-Fi BoosterPack paired with the sensor, and this will interact with the cloud through a REST API. And for those who haven't done any web development before, this is simply how the internet works today. Web services such as Google, to Facebook, to Twitter, to Fitbit.com, to your Nest, they all interface through various REST APIs, and that's simply how they leverage each other's resources and information. And Temboo is a great partner of ours. We've actually worked with them and enabled LaunchPad support in their web service. So through Temboo's web service, we can actually generate code that we can compile and flash to our hardware that will enable our LaunchPad to interact with hundreds of different web services. One of them being a web service called Nexmo. Nexmo provides a set of APIs that allows our LaunchPad to trigger voice calls. And that's exactly what we want to do here in this particular demo. Trigger a voice call when my moisture sensor here detects water. So let's go ahead and start developing the software side of our system. Let's plug our LaunchPad in over USB. And switching to the computer here, I'll minimize our diagram. What you'll notice is that I'm actually going to do my development here inside of a web browser. So I'm not going to open up a traditional IDE, all of which is going to happen here inside of my web browser. I'm going to navigate to a website called dev.ti.com. And this is a web portal that we built to enable developers to rapidly get to production. We want to enable you to go from demo to evaluation to prototyping and beyond. And through dev.ti.com you'll be able to do that. Here you can see that there are 3 tools available in this portal today, all of which support the MSP432 device. The first one here on the right side is called TI PinMux. This is a tool that will generate code for you. It'll generate header files that will configure your I/O pins and peripherals of your MSP432 device, all through a interactive graphical interface presented to you inside of the web browser. The second tool here is Code Composer Studio Cloud, or CCS Cloud. This is the tool that we'll be using to edit and compile the code that will flash to our hardware that will generate that call whenever moisture is detected. And then lastly, we have Resource Explorer. This is a really nifty utility that aggregates all of the relevant development information and resources you need to be successful at time of development. And the MSP432 device is also supported by that tool as well. Other TI devices are supported by these cloud services, but the MSP432 is absolutely supported by each of these tools here. So let's get started by clicking on Resource Explorer. And opening up that tool, again, it allows me to drill down to various development resources for various devices. And I can drill down in various ways. I can navigate through this through this folder structure here, and I can find the device that I care about. I can search by keyword, or I can click on this drop down here, and I can select the development tool that I'm using. In this case, I have the MSP432 device here, so that's what I'm going to click on. And by clicking on that icon, Resource Explorer will filter and provide me and serve up all of the content available for the MSP432 device. I don't have to go through Google or the web to search for all of this information. It's all presented to me very quickly, thanks to Resource Explorer. And you'll see you've got things like documentation, datasheet, code examples, even the hardware design files for the LaunchPad are available here as well. But for our particular system here, I want to first verify that my analog sensor is working, and I'll do that using Energia. Energia, if you're not familiar with it, is a framework of intuitive, easy-to-use APIs that allow us to interact with the peripherals and functionality of our microcontroller device, all through a hardware abstraction layer, or HAL. So Energia provides a very simple way of controlling our hardware, and you'll see just how simple once we dive into the code here. So I'm going to go ahead and click on Basics and Analog Read Serial in the Energia section of Resource Explorer. And this will allow me to see a particular code example, Analog Read Serial. I can click on it, and TI Resource Explorer will allow me to scroll through and take a look at the code, make sure this is exactly what I'm looking for. I can click back here, and Resource Explorer also provides me with a few other options. I can download it locally to my hard drive, or I can click on this cloud icon to import that code example into CCS Cloud. So I can actually edit the code and compile it to my hardware. And that's exactly what we want here. So I'm going to click on the cloud icon here. There you go. Now I'm going to click on Analog Read Serial. So we can see that inside of CCS Cloud, I have my own workspace served up. And this allows me to do some development here in the office, for example. I can log off, go to the lab, pick up where I left off, log off, go home, pick up where I left off. And all of my code is going to be hosted here in the cloud server. So we can see here I do have the project that I imported earlier. I can click on it and click on the .ini file. And this is my Energia sketch. And if you haven't developed on Energia before, Energia basically breaks up your application into two main sections. You have a setup section and you have a loop section. Anything you place here in the setup section runs once at the beginning of code execution. This might be where you configure variables or configure your peripherals, and this will basically set up the foundation for your application. Here in the loop section, this is where your main application lives. Anything you place between these two brackets will just loop forever and ever. So with the analog read serial example, this is basically going to read the analog value coming from my moisture sensor, and I want to print those readings to a terminal on the computer, so I can actually get that visual confirmation that my sensor is reading meaningful values. So the first thing I need to do is I need to configure my UART, and I can do that with one line of code thanks to the Energia APIs. Serial.begin is an API that allows me to do just that. I simply need to provide in the parameter of my baud rate, in this case 9600 bits per second. And with that one line of code, my UART is ready to use. I didn't have to worry about clock dividers or how fast my microcontroller is running. Energia handled all of that complexity in the background. With that one line of code, it's able to simply configure my clock appropriately so that I can get that 9600 baud rate. And now that my serial UART is ready to use, I can use it with the serial.println API, and I simply pass in a string. Hello world. Awesome. So setup's complete. Let's jump to the loop section. I'm going to use another Energia API called analog read, and I simply need to pass in the pin that I want to read from. And in this case, if you remember, my moisture sensor is hooked up to pin 23, and that's what I'll pass in as a parameter. And I want to save that output to this variable called sensor value. And just like before, let's use the serial println API to print that value to the terminal, and let's go ahead and delay by 100 milliseconds afterwards. So now in loop, I'm basically going to get a new sensor value. I'm going to print it to the terminal, and I'm going to do so every 100 milliseconds. So I'll get 10 readings every second. So let's go ahead and compile this code, and I can do that by clicking on this hammer. Before I click it, I want you to take a look down here in the console, and you'll just see just how fast CCS Cloud can compile our code. It's going to send the source code to a server, it'll compile it, and it'll present back to me a binary file, all very, very quickly. So I'm going to click on this hammer here, and you'll see that my build is already finished. It took less than a second. And the build, the binary file, is now saved here in this new debug folder that's inside of my Project Explorer window. So now that I've got the binary file back, I can simply flash my local hardware by clicking on the green button here. So let's go ahead and click it. And you can see now that it's trying to flash that binary file to my local hardware. So let's give that a second here. There you go. You can see now that the code is flashing to my hardware. And flash successful. So you can see the device is resetted and now code is executing. And what's really nice about CCS Cloud is that there's a built-in terminal or serial monitor, and I can access it by clicking on Target, Connect COM port, and my LaunchPad is hooked up to COM port 165. You can verify which COM port you're using by looking at your computer's device manager. And again, I want to use 9600 as my baud rate since that's what I've configured here in the code, and I'll click on OK. And now you can see here in the terminal, I get a stream of zeros, basically indicating that there's no moisture at the sensor. I've got a cup of water here, and I'm going to drop the sensor into it, and you'll see that those readings will increase. So you can see 0 when there's no water. I drop it into the water here, and you can see that my reading is up to 600, 599, etc. Remove it, goes back down to 0. Drop it back into the water again, and again we get those higher readings. So we've just confirmed that our hardware is indeed working and our code is enabling us to read that sensor effectively. So that's great. We're able to read the sensor value. So now that's a form of input into our system. But now I want to trigger the voice call. I want to interact with the cloud only when moisture sensor exceeds a particular threshold. And that's where Temboo comes in. So again, Temboo is a partner that we've been working with, and they provide a really nice interface for generating code for our hardware that will allow it to interact with those various websites and web services. And we can learn all about TI and Temboo's collaboration at temboo.com/hardware/TI. But I'll click on the home page here, and I've already signed into my Temboo account. You can create your own, and they provide a really nice free tier, which is ideal for evaluation and prototyping. They basically provide you with 1,000 free API calls a month for evaluation and prototyping. Here on the left side of the Temboo website, let me zoom in, is a list of all of the web services that Temboo supports. So you can see Amazon is here, Dropbox is here, FedEx, to Facebook, to even Fitbit.com. So Temboo can generate code for any of these web services that we can ultimately compile and flash to our hardware. But in this case, I want to use a cloud service called Nexmo to trigger a voice call, right, whenever my moisture sensor detects water. So I'm going to click on Nexmo Voice Text-to-Speech. And Temboo provides us with a really nice interface for providing a few parameters that will allow Temboo to generate that complete Energia project to allow our hardware to interface with the Nexmo cloud. We can see Temboo has that integration for TI LaunchPad and the CC3100 BoosterPack. I simply need to tell Temboo what hardware I'm using so it can generate the appropriate code. And I'll scroll down here, and Temboo only needs 4 parameters to generate the Nexmo API calls. One, I need a Nexmo API key and a Nexmo API secret key. I already have a Nexmo account, and I've already paired it with my Temboo account. So I click on this drop down and click on Nexmo, and it will import all of those Nexmo credentials into the appropriate fields here. Now I simply need to provide the text that I want to have vocalized to me whenever my phone starts ringing. So I'll type in alert. Alert. Hello, Adrian. Your house is flooding. Good luck with that. So this string will be flashed to our microcontroller, our MSP432, and through a API call, it will pass that string up to the Nexmo cloud service, and Nexmo will then vocalize and do text-to-speech conversion, and I'll be able to hear that vocalized to me when my phone starts ringing. The last parameter is the cell phone number that I want to call. In this case, this is my number. And just like that, Temboo has everything it needs to generate a complete Energia project that we can ultimately compile and flash to our hardware that will allow our MSP432 device to call my phone every 30 seconds and relay to me that message that we typed in earlier. So this is a complete Energia project. This isn't simply a code snippet. I can actually copy this code by clicking on the copy button here. I'll jump to CCS Cloud. I'll get rid of all of this code that we typed earlier and paste it in. Temboo also generated a header file, and I can scroll down here to the bottom. And this header file includes my Temboo credentials as well as my Wi-Fi SSID and password. So I do have a hotspot here, so this is what we'll ultimately be connecting through. So I'm going to again click on the copy button and jump back to CCS Cloud. I do need to create a new file. I'll right click on my project, click on new file, and type in Temboo account.h. And I'll go ahead and double click on it. I'll get an empty.h file here, and I can paste in the Temboo header file that we generated earlier. Now I can actually compile this code and flash it to my hardware, and this will basically allow my LaunchPad to call my phone every 30 seconds. But that's not exactly what we want. I only want to call my phone when moisture is detected. So using some of the IDE features of CCS Cloud, let me scroll down to the loop section of the code Temboo generated, and I'm going to click on this arrow so I can actually do code folding. I can sandwich up all of that code inside of that if statement, and now I can see everything inside of my loop section. And I only want to run the code inside of loop if my sensor value exceeds a particular threshold. So using the code that we wrote earlier, let's go ahead and read the analog value coming from pin number 23 and save it to a variable called sensor value. And then again, let's go ahead and print it to the terminal so we get that visual confirmation of the sensor readings. Pass in sensor value as a parameter. And then lastly, only if sensor value is greater than, let's say, 400, only then should it run the code that Temboo generates. So I'm going to go ahead and encapsulate all of this code inside of a if statement. And let's go ahead and indent that. So just like that, we can actually compile this code, flash it to our hardware, and basically our LaunchPad will only trigger that API call through Temboo, ultimately making that API request to Nexmo when moisture is detected. So again, let's hit the hammer button to compile our code. Move this over here. There we go. Jumping here, we can see that the build is finished, or our code is finished compiling. Now I'm going to go ahead and click on the green button now that we have the binary back from the server to flash our hardware. So now it's going to go ahead and flash this new code to our LaunchPad here. So let's give it a second to flash that binary. And now I've got my phone here. I'm going to go ahead and turn up the volume, make sure you guys can hear it when the phone starts to ring. And once I pick up that phone call, I'll be sure to put it on speakerphone so you can hear the message that we typed into the code here that will ultimately be vocalized to us. So you can see now the code is flashing into the memory. Almost done. There we go. Device is now running. So I can jump to the terminal window here, and you can see that my LaunchPad is now trying to connect to Wi-Fi. So you can say Wi-Fi OK. It was able to connect to my hotspot, and now we should start to see a stream of zeros. So basically, the first thing it does is it connects to Wi-Fi. It said Wi-Fi OK, meaning it established a connection, and now we're just polling that sensor. And you can see it's a 0 at the moment because there's no moisture being presented at the sensor. But once I drop it into the cup of water, we'll see that the readings will spike up in the terminal, and ultimately it will try to trigger that API call. So let me drop it into the water here. You can see it's now trying to run the text-to-speech API. And now we should just wait a couple of seconds for that phone call to come through. So let's wait here. There you go. You can see now my phone is ringing. I'll pick it up and put it on speaker.
Alert. Hello, Adrian. Your house is flooded. You've lost the pad.
And that's it. So we got the phone call. You can see that it did indeed vocalize that string to me. And within about 15-20 minutes, we created a internet-connected moisture sensor. What's exciting about this is that we can very easily switch out the various inputs and various cloud actions that we want to trigger. If I wanted to generate that voice call based on ambient light instead, I can simply switch out that moisture sensor with this ambient light sensor. Or if I want to do it based on volume, if I wanted to create a alarm system based on sound, I can do so with a microphone, so that anytime someone were to, let's say, break into my home and I can hear or wait for that loud sound of the glass breaking, I can trigger that voice call as well. And not only can I change the inputs, I can also change the cloud side activity with the help of Temboo. So in this case, I generated a voice call with Nexmo, but if I wanted to trigger a SMS or a text message, I can do so with another cloud service, and so on and so forth. So hopefully that was exciting. You guys can do everything that I've done today with the hardware that I've demonstrated, and all of the cloud services that I use are all available today. And you can learn more about MSP432 and those available resources at dev.ti.com. And you can learn more about Temboo and TI's collaboration at temboo.com/hardware/TI. So thank you for watching.